Hello and welcome to this further maths video on solving cubics and quartics. So let's have a look at the first question. We are asked to essentially solve this cubic equation here. So first of all, it says show that x minus 2 is a factor of f of x. So you know that what we need to do for that is look at f of 2. And if f of 2 is equal to 0, then we will have shown that. So make it very clear that you're substituting in 2 cubed minus 6 times 2 squared plus 21 times 2 minus 26. And when you work this out, you're going to get 8 here plus 42 here is 50. Minus 26 minus 24 is 0. A little tick. Hence, x minus 2 is a factor of f of x. So we've done the first part of the question. Now it says, hence find all the roots. Because this is further maths, we're expecting the other two roots to be complex numbers. So what we're going to do is, first of all, divide this polynomial by x minus 2 to find out what the quadratic is that we're left with. So we're going to do long division. There are other methods of doing this, but we're going to do it by long division here. So we've got x cubed minus 6x squared plus 21x minus 26. And we're going to do long division for this. So we say how many x's in x cubed? X squared. That gives me x cubed minus 2x squared. Subtract that. That gives me, so be careful with your negatives here, minus 6x squared. Take away minus 2x squared. So that's minus 4x squared plus 21x minus 26. So then we say that's minus 4x. So I get minus 4x squared plus 8x, and when I subtract those, here I'm going to get 13x minus 26. So looking there, that's going to give me plus 13 at the end. And I'm going to finish this up here. Obviously, we're a little short on space. It is important, even though you can see that 13 times that is going to give you what we've got on that line, it is important to carry it on. So I would say 13 times x, right underneath is 13x minus 26, and subtract it and get 0. So just make it absolutely clear that you've done all the work for that. So we now need to find the roots of the quadratic we've got here. So x squared minus 4x plus 13 equals 0. And we could do that by completing the square. We could also use the quadratic formula. You can use your calculator, but if it says show using algebra, then you need to be able to show it thoroughly. So we're going to say here that x minus 2 all squared minus 4 plus 13 equals 0. So that gives me x minus 2 all squared is equal to, so that gives me 9 here, but when I move it over to the other side, that's going to give me minus 9. So I get x minus 2 all x minus 2 is equal to plus or minus 3i. And so then x is equal to 2 plus or minus 3i. So my roots for this equation are going to be x is equal to 2, x is equal to 2 plus 3i, or x is equal to 2 minus 3i. Question 2, we're asked to show that x squared minus 1 is a factor. Now they're trying to catch you out here. You can't use the factor theorem in quite the same way. So what you need to do is long division here. So we've got x squared minus 1. Looking at this, if you notice that you've got x to the fourth, x cubed, you haven't got any x squared terms, and that's a time to watch out. So you've got 5x to the 4 plus 8x cubed. I would put in plus 0x squared minus 8x minus 5. Then doing the long division, we're going to say x's into that go x squared. So when I multiply that down, oh, I need 5x squared, don't I? I get 5x to the 4, and then I get minus 5x squared, and I'm going to put that underneath my x squared term. Subtracting, I get 8x cubed plus 5x squared minus 8x minus 5. So I'm going to have 8x here. So I get 8x squared, sorry, 8x cubed rather, minus 8x. So I'm going to put that there. Subtracting, I'm left with 5x squared minus 5. It's good because I can see that that goes. It's going to go into it 5 times, so 5x squared minus 5, and that gives me 0. Okay, and then I might write remainder is 0. Therefore, x squared minus 1 is a factor. Now, the second part of this question, find all 4 roots. So we need to find the roots of x squared minus 1, and we need to find the roots of this expression here. So the roots of x squared minus 1 are going to be x equals 1 and x equals minus 1. And then we need the roots of this quadratic. So the roots of the quadratic, I would use the formula for that. You don't really want to be completing the square when you've got a coefficient of 5 for the x squared. So I would say here x is going to be minus b, which is minus 8, plus or minus the square root of b squared, which is 64, minus 4 times a times c, all divided by 2a, which is 2 times 5, which is 10. And when you work that out, you end up with minus 4 plus or minus 3i over 5. So you could get this from your calculator, but the question might say using algebra. So you need to be able to do that. So those are 2 of the roots. The other 2 roots are going to come from when x squared minus 1 equals 0. This is the difference of 2 squares. We've got x plus 1, x minus 1 equals 0. So my overall roots are x equals 1, minus 1, minus 4 plus 3i over 5, and minus 4 minus 3i over 5. And that gives me my 4 roots. Right, the last question is a quartic. So a quartic is an equation with a 4th term. So let's have a look at how this works out. We're told 2 of the roots, 2 minus I and 1 plus 3i. Find the other 2 roots. You know that complex roots occur in conjugate pairs. So one of the other roots is going to be 2 plus I. The other root is going to be 3 minus 3i. Sorry, 1 minus 3i. Right, find the sum of the roots. Well, the sum of the roots is going to be 2 plus I plus 2 minus I, so that's going to give me 4. And here we've got 1 plus 3i, 1 minus 3i is 2, so that is 6. Finding the product of the roots, to multiply them all together. Now, when we multiply 2 minus I by 2 plus I, we're going to get 5. When we multiply 1 plus 3i by 1 minus 3i, we're going to get 10. So the product of the roots is 50. Then it says find the values of A, B, C, D, and E. So what we need to do is recreate the equation that would lead to this. Just in a similar way, if you knew the roots of an equation were 3 and 7, you would know that the equation was going to be x minus 3 in a bracket, x minus 7 in a bracket. So we're going to do exactly the same thing, but we do need to be quite careful about it. So we've got x minus 2 plus I. We've got x minus 2 minus I. Then we've got x minus 1 plus 3i and x minus 1 minus 3i. We then want to multiply this out. So this equation is equal to 0. So multiplying these out, we get x squared. Now, when I multiply out the x terms, just of these two brackets here, I'm going to get minus 2x minus ix, then I'm going to get minus another 2x plus ix. So the i's will cancel out. That's part of the point of it. So we get minus 2x minus another 2x, so we get minus 4x. Then when we multiply these together, we get plus 5. Same thing here, multiplying this together, we get x squared minus 2x, because the 3i, the minus 3i will cancel, plus 10. And we then need to multiply all of this out. Do this carefully, and I would set your working out in stages. So multiply all of this by x squared, we get x to the 4th minus 2x cubed plus 10x squared. Multiplied by minus 4x, we get minus 4x cubed plus 8x squared minus 40x, and then multiply everything by 5x squared minus 10x plus 50, and then total everything that you've got, and that gives you x to the 4th minus 6x cubed. We've got 18 plus 23x squared minus 50x plus 50. So then equals 0. The values of a, b, and c. A is equal to 1, b is equal to minus 6, c is equal to 23, d is equal to minus 5, minus 50 rather, and e is equal to 50. So now you've seen how to solve cubics and quartics, and you need to go away and practice doing some of these kinds of questions.